Hi, I'm Kerry with Optical Structures. Today we're looking at the Lumicon Easy Guider configured for DSLRs. So the Easy Guider is an off-axis guider right here. It's located between the telescope and the camera, and it has an internal pick-out prism that directs some of the unused light out to the guide camera. So we're going to pull this apart and take a look at it and see how it works. So if we look in the camera, we see the pick-off prism and the main detectors down in the hole. It attaches to the camera like this. Take these thumb screws loose. Got a little more to go. So you install a T-ring on your camera, and then this is part of the Easy Guider. It screws in there, and then it lets you attach it to the camera and kind of position the angle how you need. I position it what looks like it's upside down. That seems to work the best. So we'll put that back together. And then this is a ZWO Mini. It's a guide camera that we provide an extension tube to go with, and you install it like that. The manual talks about setting up the guiding assembly and how to bring everything to focus. We install that. So the basic procedure is point this at a bright star, focus the main camera, and then adjust the focus for the guide camera. Now the guide camera is hooked to a laptop over here, and also has a cord that's hooked to the mount. So the way the auto guiding works is we use auto guiding software. I prefer what's called PHB2, but there's many other software packages. The guide software acquires a star image off the guide camera and tracks it, and then the guide software calculates the amount to move the mount and relays to the guide camera to send a signal to the telescope mount to adjust its position. And that cycle happens every 2 to 5 seconds, keeping the telescope on. So there's a few reasons that we'd like to use an off-axis guiding system. The first reason is that we're working at the focal length of the telescope versus using a small auxiliary guide scope. So we've got higher guiding accuracy. So that's one reason. The second reason, is probably the most important reason, is that in many telescope systems, as the telescope pans across the sky or tracks across the sky, you can get what's called a differential flexure between the main camera and an auxiliary guide scope. For instance, this telescope has a long focuser. It's extended a lot, and it actually has a little bit of wiggle in it. When I move it up and down, I can see that it's got some sloppiness. So if I'm guiding with a piggyback guider through a small guide scope, that guide camera will not see this motion, and we'll still get trail images. But in contrast, the off-axis guider will detect that flexure or that slop or motion. So that's a primary reason, is we won't have differential flexure or differential movements while we're guiding.